Okay, so in this video, we are going to recalculate torque for the problem that we solved in the previous video, but we'll do it using the other formula that we had, okay, which is R perpendicular times F. Okay, so the problem itself, you'll see that with this definition, it becomes really easy to tackle. Okay, all you need to figure out is the perpendicular distance of the force from the point, from the pivot, and then everything is okay. The direction of the torque is unaffected by either of the two definitions. We still know that the 100 Newton will create a clockwise rotation and the 80 Newton will create a counterclockwise rotation. Okay, so here's what we do. Just simply extend the force, and we know that when we extend this force, the perpendicular distance of the force from the pivot is simply equal to 3 meters. Okay, and we do the same thing for the other one, and we notice that the perpendicular distance of the 80 Newton force from the pivot is 4 meters. Now that we have these individual distances, the torque due to 100, okay, is going to be equal to 100 times 3, which is 300 Newton meters, and it is in the clockwise direction. So this is, or creates a clockwise rotation. So this is a positive torque, this is a negative torque. Okay, and then I have my tau 80, which is equal to 80 times 4, which is 320 Newton meters, and this we know clearly creates a counterclockwise rotation, and therefore being a positive torque, and therefore my tau net is once again equal to 20 Newton meters in the positive direction. Okay, now the advantage of this method is that we really don't need to worry about angles, okay, and that somehow always happens to be the trickiest part. Like, people always make mistakes with the angles. It's something that happens. So if you can avoid any of these pitfalls, then use whatever you can. So in this case, again, if we know the perpendicular distances, life will be very easy. In fact, when we do things with equilibrium, we will use this perpendicular distance method a lot, and see how it really makes life very easy. Okay, so hopefully you understand this problem, and compare this one with the previous one and see how easy it is to use the perpendicular distance method. Now, you may not be able to use it all the time, but whenever you can, go ahead and use it. All right, that's it.